I feel happy to be here and to present you a little bit my thoughts. And at the meantime, I read the explanation in old battle horse in the field of engineering science and engineering or design science. And therefore, let me show you a little bit from this perspective some aspects I think we should have a look at in the future. Human behavior. You know all the things here in Dubrovnik. It's not necessary to heat, but everywhere in the winter, for example, it is very convenient that we have such a device. The original stuff is coming, product and engineering generation is coming from the Romans, but we have improved it more and more. But what does it mean? If we heat the room, we have higher energy consumption. And this maybe will lead to pollutions, for example. So it is easy a solution, dress warmer and heat less. So the user could clarify the situation very easy. We have this in a lot of fields. Think about energy pollution by taking the plane. Why coming by plane to this nice country? We could come by bicycle. Huh? Fly less, so we have less pollution. Or in this machine, we could less often fill the machine and use it. Is this realistic human behavior? You know, it's a semantic question. No, it is not. What is the problem with this? In my opinion, we are split it in two persons, in a citizen and in a customer. I make it on an example with cars. You know that I am very much active in the automotive industry. And we know when the young people, also young people, come in the showroom, come with the idea to buy a car, they look for a cheap car, an ecological, positive car, and then they go in the store and they leave it with something like this. You cannot believe it. Actual information. Ford will stop all production of cars less than D-Class. And D-Class is SUV in the States. They will not produce them anymore because there's no business. Oh. My opinion, we have here a rupture in our hearts. The citizen with values, protection of environment, for example, fair access to mobility for all. And there's a second person the customer needs, driving pleasure, for example, in the cars, or social differentiation, all of these stuff. And I think we all have these two rules in what we are doing, as a citizen and as a customer. This is a dilemma, because our behavior as a customer often has an impact which are contrary to the values of the citizens. But most of us, these guys here not, but most of us decide to the customer side when they have to make customer decisions. Let me make it on an example with mobility, individual mobility. What is the need? We have a need for individual mobility, but there are also some problems, you know. Rising CO2, for example, time loss, and health issues, for example. So what can we change? How can we change this human behavior? Now, yeah, the first part is by government. It's very easy. It's very easy if you are in a dictative system. In the former German Democratic Republic, it was by order that the number of vehicles is so small, but very worse, so that they could reduce the number of cars. But is this a solution? Legislative bans, for example. In Germany we have a diesel discussion. It is absolutely unbelievable what happens there. In complete Germany, from more than 800 measurement stations, there are only 3 which catch the limit. And this will be in the next 2 years also be under the border. And the proposal is only to limit some routes in Hamburg, for example. And we have a very, very big discussion. And education. Courts are ignored, customers feel patronized, and delayed effect in education. But my opinion is that in education we should do something in this direction. But now comes the key point. In my opinion, the society implicitly demands technical solutions for its problems. And this is our job, to deliver these, appropriate the right technical solutions. For example, smart traffic management systems as an answer, or alternative drive concepts, all this discussion, or solutions with an ecological footprint. That we have there big problems. You can see on the discussion about battery electric cars. The battery electric cars are, in my opinion, a dramatic failure because of pollutions, because the ecological footprint is very, very bad. You need roughly to drive 80 to 100,000 kilometers to come to the CO2 hints of the battery production, to overcome this. And if you think these are small cars, which maybe drive 10,000 kilometers per year, you need more than 10 years to come equal to the petrols. I'm not a diesel fan. I'm a fan of the Wasserstoff. Yeah. So many problems of society cannot be solved exclusively by political or legal investigations. We need to help the society. There's a demand for innovations. This is, in my opinion, a very important point. We have a responsibility to help our society, to help our people all over the world to overcome the problems. What is innovation? Innovation is, in my opinion, one of the most wrong used words, because innovation, if I make a test, everyone says innovation is something new. No. Schumpeter says an innovation is something new and successful. And this is a very big difference. Most guys who speak about innovation speak about inventions. This is something new. But you need additional so-called product profile. This is the need of the people, the need of the customer, the need of society. And then you need the process of diffusion. You can see it on e-mobility actually in Germany. The diffusion of battery electric cars in Germany is very, very slow. Very, very slow. We are below 2% of the complete passenger cars. So there is actually no innovation with these. Yeah, if we bring this together to a model, we can say, okay, the society has a pull on the companies to deliver these technical solutions, a demand for technical solution, and the companies supply the society with technical solutions. This is a process, and the companies need skilled people, they need methods, they need personnel, and where this coming from, that's clear in my opinion. This expertise has to come from what we call research organizations, from our universities, from us, from our community. We have to bring in these skilled people to overcome or to make this process running. Again, an interesting word for you maybe. In Germany, the skilled people in engineering will be the biggest issue in the next years, because the old battle horse like mine are going to retire, and the number of engineers which is coming after is too small, much too small. And so we have a real problem in Germany. Okay, so the companies have a demand for expertise, and we have to supply. For example, in KIT, our master students normally have a contract before they have made their master thesis. And yeah, there is a big demand. Now let's have a view on research. I speak about engineering research, engineering science, not about the other scientific groups. This is important to understand. And what is the idea of engineering science? I'm on the chair of Professor Rettenbacher from 1845. And this Rettenbacher was the founder of the scientific engineering, and I will make a remark a little bit later about his thoughts. And the key point is that engineering science has not only to analyze, to build a house of knowledge, but also to synthesize solutions. This is a big difference. Engineers have to synthesize solutions, not only analyze. Design engineers, especially. And if you have a look to this research, there is always a discussion in Germany about basic design and applied design, research, basic research and applied research. This is, in my opinion, a stupid discussion. It makes absolutely no sense. What there is to discuss is the horizon. The horizon when this knowledge turns into solutions. When this knowledge comes to innovations. Innovations in the sense I defined it. And normally I speak about three horizons. The short-term horizon, 0 to 3 years, roughly, for example, the next generation of a smartphone. Midterm, 3 to 6 years, the next product generation of a car, or 10 years and more, or 8 years and more, the future generation of drive concepts. For example, hydrogen cars. And on all these, when we match these horizons with our model, then you can see that the society, there are products already in market. The companies normally do the short-term things, research in industry. The mid-term things is done by industry and us. And the long-term perspective normally is a typical domain for the research which is done in universities, for example. And we have to accept, when we apply the knowledge which is born in long-term research and give it to the companies, and in the companies to transfer it to innovations, that we have a loss. This is important to understand. We have a loss. We normally say that at nearly 80 to 90% of the body of knowledge which is created never leads to innovation. Yeah? This is important to understand. Okay. the same as for technical systems, we can also make this model for design processes and processes. What we are doing also. I will show you these on examples. Oh, it works. Old battle horse, so no problem. Yeah, I will show it on some examples from our research. For example, short-term methods for early product validation. Mid-time is design guidelines for new manufacturing technologies, for example. And actual long-term project is design process for system of systems design. This is what we are doing with the big group in Karlsruhe. What are the founders and the executors of the design? If we have design in companies, the founder is clear, it's a company. And normally, a lot of these things are done in the company itself, but more and more, they do not do any research in the companies, they transfer it. So in my opinion, this here is a very important field where we can integrate our body of knowledge in the short-term design processes and research processes. Then we have a research with company. This is a typical research which is founded by the company and a public funder in combination. In Germany, it's very prominent, very important. And here, the company and the research organization are doing it, for example, the universities. And then for companies, for the future, you see this is a long-term perspective. This is a typical center of excellence of the DFG in Germany with a 12 years perspective. Here we are doing, this research is normally founded by a public founder. Why? It's very simple. The companies do not have this horizon. The board of a company has to report every 3 months its financial data. They have no idea what is in 12 years or something like this. But they should. Okay. Now I will combine this a little bit. For example, the research in companies. As we said, the company is the founder, and this done in both in research organizations and in the companies. Here's another important part: research with companies. I want to give this appel to you. Do a lot of research with companies, especially on design processes, methods, and tools. Go to real-world applications. Only the validation in the real world gives us, at the end, the benefit that we want, the impact on society, what we want to do with our research. Therefore, this is an important point. And research for companies is also in midterm research and especially in the long-term research, as well as on systems, as on design processes and methods. Let me explain a little bit the model, how this works together, in my opinion. This has to be a very strong linkage, in my opinion. When I started in Karlsruhe 22 years ago, there was no research on design methods and no research on methodologies. They did only systems design. And I changed this, and I strongly believe that the integration of doing research on systems and doing research on methods can help you to overcome problems and can help you to come to real-world design methods. And then there's an enabling path from the research for companies on this here. And there are 2 additional contacts here from research for companies, in research with company, and enable also this here. And now I want to show you in some examples how it works. And these are all examples from my work at EPEC. Long term. Long term, just 4 examples. I was integrated in 5 centers of excellence. Here you only see 3. And these projects you see here, for example, the ceramics runs from 2001 to 2011. And there we did some research in microsystems or here on ceramics. Actually, as I explained, these long-term research, what we are doing is systems of systems design processes. Let me focus on these ceramic center of excellence. What have we done there? We have the research object was to integrate this new material in applications in drives, and to do it from the basics, from the compounding this materials, the ceramics, up to solutions. And the program definition was investigation of the use of engineering ceramics and development of innovative applications with engineering ceramics. This was invention, clearly. And the Center of Excellence started also with the key idea: we make inventions, new solutions. And the initiator was the research organization. I show you now one example. What happened there? We developed completely new tools, new methods to test it and to develop it. And here you see an example. This is a clutch or a brake, you can say also a brake, and you see the problem. The ceramic is so huge in its power that you have now wear on the steel side and not on the lining side of the brake, for example. And so we could develop completely new solutions. We could reduce the density of this system by 40% in real-world applications. And we did some expertise, and we did new test methods, and we did new design methods. For example, there's a design catalog behind how to design with ceramics, and so on. The benefit for society is to have these potential future things. We are 2005, now we are 2018, and at the end I will show you where it works. Next example, the midterm. Here you see, again, project from us. For example, the PGE. Some of you were with us with Porsche. This is, in my opinion, midterm research. This model, product engineering, generation engineering model, will infiltrate already some companies and will use them. I go to another drive example. Here we are working on an electric drive for cars where the engine runs 30,000 RPM. So we need, it's a very special one. The drive, the electric motor is this size for the car. We will go in the next step to 60,000 RPM. And now you may ask, yeah, what has this to do with the basic research? The long-term research. The methods and the procedures, and especially the design methods and the validation methods for these new gearbox is coming out of the long-term research from the ceramics. Here we have some special ceramics part in. Okay, here an example how it looks like. This is the design of this solution. What is the benefit for a company? Resource saving. Yeah. The big problem with the electric engines in cars is that you need a bunch of stuff which is very seldom and expensive. And if you can make the electric motor smaller, then you can save a lot of this material. For the research, we have application. We know that our methods run, and we know that some of our ideas, research ideas, failed because the method does not function. But this is also knowledge. And for society, we have more environmentally friendly, ecological friendly, and footprint-friendly solutions for the future. And now let's come to the research in companies. I want to make you an extreme example. One of my colleagues here may know this. Here it is, again, a bunch of projects. This is what we are doing there. This is very close with companies together. And there's one big project since 22 years I make with students here, and this is with students solutions for them, innovative solutions. And I will go to the clutch again, and you see what the need from this company was they need a damage model for their clutches and brakes to integrate it in the drive. Oh, thanks. To integrate it in the drives. And here we took the measurement equipment, what we developed during the long-term research Center of Excellence, to solve a problem in 6 months for them. We developed a method where we can interpret and where we can measure and where we can model this contact behavior. And the project initiator here is clear. It was the OEM. He wants to have these, and so he has to pay for it. It's clear. What is here transferred is knowledge from the product in today and knowledge from the methods and tools in the real-world application. And now, from this research we have done in 2005, for example, or 2008, now, because this solution is now in active product development process at the car maker, now it's an innovation because it's successful. And initial situation, OEM needs something to predict these damages. And there was only 6 months' time. They need a solution, and they need a measurement system. And at the end, we found these solutions. And you see here one example. This is a model, what is created. It is, you see the temperatures on the surface of this structure. We measured it, and then we modeled it, and now the customer has a solution. The benefit is increase for the detection of damages, probably. For our research, we have got new impulses. These new temperature measurement techniques has already led to new DFG long-term projects. And so the loop is always closed in this innovation and knowledge, building a body of knowledge process. And they are coming to save our more cars. Let me make some conclusions. All results of design research should aim to benefit society. I know this is a strong word, and maybe we will have a discussion about that, but in my opinion, it is necessary. Our research has to benefit the society. Research projects have different time horizons, and design research is conducted with and for companies and society. You can add to companies society, no? Because I showed you that the way through the company, a company is the way from the invention to the solution. And research and invention losses must be accepted, as I have shown you. Therefore, DFG research, if you do a DFG research project, is accepted that what is coming out is not a real solution. Research is always risky, and we should have this in our mind. And at the end, we as researchers have to build the basis for the future innovations that we should have in our mind, and therefore we should do it in these horizons. You see the outlook. How will research, will be research in, with, and for companies in the future? You see here some examples on the different time horizons. I showed it to you. Products, specific product and process expertise, generalized knowledge. And now here comes the key point, the perspective of the researcher. We have to underline the body of knowledge, to underline it with young people, what I see here, with young researchers and designers and engineers which can work on this field. So what can we claim? To train for future researchers and developers, we have to look at the future of design research. Need for scenarios for design research. In Karlsruhe for the WGEP, we actually develop such design scenarios, design research scenarios. And we have to increase application speed. We need agile research and agile development. Please don't misunderstand me. Research always needs time. But because of a lot of bureaucratism around this, in Germany, we lost a lot of our speed. And here I think also on the political level, we have to up speed and we have to make changes. It cannot be that the time from an idea of research to a proposal which is coming needs 4 years or something like this. Then the idea is already gone. So what is the mindset? Conjunction of theory and praxis. I think as these, you see, I took this word, the old bell horse, will give this to you, to the young of you, combine theory and praxis. This is very important. This is a key factor for success. You cannot research design when you never did design. You cannot research methods in engineering when you never engineered something. Then, thinking in systems. In my opinion, this is a key factor. Thinking in systems, systems of systems, as I explained, this is what we are actually now doing in our research. And all research must seek to benefit of society, independent of its time horizon. Also, if we are doing research in a long-term perspective, in Germany, the DFG, Centers of Excellence, we should have in our mind and in our set what we are doing, that we want to come into the innovation. We want to give back something to the society. In my opinion, this is very important to understand and to do. Now, at the end, I hope you found it a little bit. I'm in deep of my heart, I'm a designer, and I designed a lot of things, and the main product I produced in the last 22 years, in my opinion, are my PhDs, my assistance researcher, which are now all over the world. And my speech should make this with the young guys. Be enlightened to give the society technical solutions for their problems. This is our job, and this is the best job you can have. Thank you very much.
Thank you very much, Professor Albers. It was a real pleasure to be here on your presentation. Now we have a few minutes for questions. So from the audience, who will be the icebreaker? Here it is. Please use the blue mic.
Professor, thank you very much. future, and I see the combustion engine, I don't see the two things together. Doesn't society, an ecological, sustainable society, require a radical paradigmatic shift? And if that's the case, how does that harmonize with your model?
Yeah. Thank you for this question. It's very interesting. You have always actually discussed about combustion engine. I'm not research on combustion engine, not at all. So I'm doing something in the drive systems in the total. But let me say it. It is absolutely clear today. It's absolutely clear in the year 2030 that all scenarios show us that we will have much more combustion engine in the world than today on the road. We will have also electrical solutions, and we will have these things. And the researchers on this field, for example, with the diesel, they have new things. They have new things. The next generation of diesel engines, this will go through the press. When you go drive with this diesel engine through this road in Stuttgart, the air which is coming out is better than what is coming in the engine because of all this filtering and so on. But you ask, is this the right way? In my opinion, no. In my opinion, we have to change the complete society in an H2 society. Only with hydrogen we can overcome the problem, because at the end the oil is limited. And we should save the oil for the chemical industry. The baddest way, what actually happens is, or a bad way, what actually happens is a battery. Because the ecological footprint of batteries is very bad. It's very, very bad. And it will lead to great problems in the next years. So for me, the individual mobility will be electrical, but with, not with the battery, but with Brennstoffzelle, with hydrogen. Yeah. But it fits perfectly to this model. Actually, what we are doing with the system of systems design in the basic research, for me it's very clear, in 5 or 10 years, then we will transfer this knowledge to the automotive industry or to society that they can handle their problems. Yeah. But as researcher, we have to accept in this basic research, when we have this 10, 12 years horizon, maybe some of the actual people, also the society, does not understand what we are doing there. Because we are ahead, but as researchers, we should be ahead. Huh?
Thank you very much. The last question here in the middle.
Thank you, Professor. I'm Tatiana Reyes from the University of the Technology of Troyes. I have some questions in that way. The urgence of the environmental aspects reduce a lot the time scale. I think maybe the question is, maybe we try to combine technical solutions with not technical solutions.
Absolutely.
And what are the role of our role to try to reduce this time scale.
Yeah.
Taking into account this urgency, and in the other way is how we can change our methods and tools to go very quickly, more quickly. Thank you very much.
Yeah. Okay. Thank you very much for this question. Let me first answer what we can do as researchers. We have to go, and this is coming more and more, to agile methods, to agile processes. We call it agile system design, where we can speed up it a little bit, and we have to do this research, how it works, and then give this to the, for example, companies where it really happens. The other point is with the ecological footprint or the ecological thing. I think you're absolutely right. Technical solution cannot be the only things, But without technical solution, it will not work. There is no chance. We will have in a few years 9 billion people on our Earth. And this is not planned from God or whomever at all. Yeah? And therefore we have, this is only possible with technical solutions to overcome all these problems and to give them, to give to all of them a good life. This has to be the target. But we can also make something in education, in maybe also in deeply discussions, in democratic discussions. This is very important too, that the society itself is changing. But believe me, I'm a little bit skeptical in this. This example what I showed, this disrupted heart in citizen and customer, is not only a model for the automotive or so, it is you find it in every field. And the decision that Ford will not produce small cars in the States anymore, this is actual.
Well, the message would be that we should behave more as citizens and less as customers.
Yeah. Yeah.
Thank you very much for the presentation. Thank you very much, Professor Albers. And now, yes, please. I think this is